Okay, here's another dimensional analysis problem. This one's a little bit longer. We want to convert 55.0 miles per hour into meters per second. And the right side I drew a slash for the per, but the P in this one still could be a slash. So this is another one of those problems where I already have a numerator and a denominator unit. So I want to write down the given. I'll do that over here. 55.0 miles, I'll write MI, over hour. 55 miles per hour. So I already have my line, and I'll draw that, and there's going to be a lot of steps to this. So I'll draw a lot of conversion factors in here. Don't know if I need to use all of those or not, but so on the top we don't want miles, we want meters, and on the bottom we do not want hours, we want seconds. So it doesn't matter which one we start with. We just need to cancel units until we get the correct units where we want them. And I'll go ahead and use the bottom one first. Let's convert hours into seconds. And if you remember from one of the dimensional analysis problems, we can do this in one step if you remember how. I have hours on the bottom, so I want to put hours on the top. And on the bottom I'll put seconds. And if you remember, there's 1 hour is 3,600 seconds. So my hours cancel off. And I can say, aha, that's what I wanted on the bottom, seconds. So I did that part in one step. So that's pretty nice. Okay, so now let's go back and let's take care of the numerator unit. The numerator unit is miles. I don't want that, so of course I'm going to put that on the bottom, miles. And I need to figure out what I need to put on the top. Well, I'm eventually, keep in mind, I'm trying to get to meters. If I knew how many meters there were in a mile, that'd be nice, because I'd be done with it after this step, but I don't. But I do know how many feet there are. In 1 mile, there are 5,280 feet. So I can use that instead. I'll do miles, cancel miles out. And so now I don't want feet, so I'm going to put feet on the bottom. And if I knew how many meters there were in a feet, I could do that, but I don't. I do know how many inches there are. There are 12 inches in 1 foot. Feet will cancel off, and now I'm in inches, which is still not what I want to be in. So I'll put inches on the bottom. And on the top I can put centimeters, because if you remember when we were talking about conversion factors, I taught you this one here that we're going to use as a bridge. And there are 2.54 centimeters in 1 inch. Inches cancel off, and now I'm in centimeters on the top, which is not what I want to be in, but now I'm really close, because I can do centimeters on the bottom and meters on the top. And we all know, I hope, that in 1 meter stick there are 100 centimeters. Centimeters will cancel off, and you'll see, aha, I finally made it. My unit on the top is in meters, so I have meters over seconds, which is what I wanted for my final units. So all I have to do is take 55 times 5,280 times 12 times 2.54, and then I'm going to divide by 3,600, and I'm going to divide again by 100. I need to do it exactly in that order. Don't try to divide by 3,600 and then multiply by 100 unless you're doing that in parentheses on your calculator, because if you do that, it'll actually multiply by 100. You got to be real careful with your order of operations. Okay, so if I do that whole thing, I'm going to get an answer of 24.5872 meters per second, but I want to worry about sig figs here. So the first thing I always check is my given. How many sig figs were in my given? 55.0 is of course 3 sig figs. And a lot of times I'm going to be safe if I go with whatever my given is, but I want to also check all of my conversion factors, and I want to see if there's any bridges. All definitions I don't have to worry about. So this first one here, 1 hour is 3,600 seconds. That's a number. That's a time definition. That's not a measurement. So I don't have to worry about that one. 1 mile, 5,280 feet. That's an English definition. Don't have to worry about that. 1 foot is 12 inches, another English definition. Don't need to worry about that. This one, though, 1 inch is 2.54 centimeters. You'll see I've switched from English to metric. So this is actually what we call a bridge. And I need to worry about the amount of sig figs here. There's 3 sig figs. However, my given was also 3 sig figs, so it's not going to matter. Now, if this happened to be 2 sig figs in this bridge, then yes, my final answer would have to only have 2 sig figs, but because you have to go with the least amount of sig figs. But it's still 3. This last thing here is also a metric definition, so I don't have to worry about that one. So the only thing I really had to worry about was this one here because it's a bridge. But I didn't really end up having to worry about it because I only had 3 sig figs, which was the same as my given. So I need to put this final answer in 3 sig figs, so it would be 24.6 meters per second. Now, what an interesting thing is you can do now is you could use this as a new conversion factor, because now I know that 55 miles per hour equals 24.6 meters per second. So from now on, if I was given another problem with miles per hour, like 100 miles per hour, what I would do very quickly would be just take 55 miles per hour and 24.6 meters per second on the top, and I would do it like this, and I could quickly convert to meters per second. Just a little trick there. Once you kind of get some conversion factors worked out, you can use those then in future problems. So hopefully that helps you a little bit more with dimensional analysis.